Settle in, slow your breathing. Tonight, we'll stroll through Earth's gentlest astonishments, the quiet facts that hide in the folds of our world. Not the headline stories, but the soft, strange truths that feel like finding a small seashell in your pocket. 100 of them. All real, all unusual, all sweet to the mind when it's time to sleep. Let's begin with the almost silent music of the planet itself, and wander onward step by step until the night takes you. 1. Earth hums even when there are no earthquakes. Seismologists discovered a persistent hum in the late 1990s, a global vibration at ultra-low frequencies around a few millihertz. It's thought to be driven largely by ocean waves interacting and pressing against continental shelves, setting the crust into a faint resonance. You can't hear it, but sensitive instruments feel it endlessly, a planet breathing in slow motion. 2. Above this quiet ground, the sky also has a soft heartbeat, the Schumann resonances. Lightning flashes around the world about 40 to 50 times a second, and the Earth ionosphere cavity rings with a fundamental tone near 7.83 Hertz, plus harmonics. It's not a sound for ears, but an electromagnetic whisper, a planetary drum you can only catch with antennas and patience. 3. In the ancient rocks of Western Australia, tiny crystals called zircons have carried memories from 4.4 billion years ago. These zircons hold oxygen isotope signatures that suggest liquid water existed on Earth's surface surprisingly early, when the planet was still cooling from its fiery birth. Imagine a very young Earth already wearing a thin shawl of oceans under a fainter sun. 4. The flattest natural place large enough for satellites to love is the Salar de Uyuni in Bolivia. This great salt flat is so uniform, with surface height variations measured in mere decimeters over vast distances, that space agencies use it to calibrate instruments. After a gentle rain, a shallow film turns it into a mirror, and the sky itself seems to walk upon the Earth. 5. The longest mountain range on our planet hides under the sea. The mid-ocean ridge snakes for about 65,000 kilometers, a stitched seam where plates separate and new crust is born. It's dark there, and yet, like a slow-growing garden of stone, it unfolds day after day, remaking the ocean floor. 6. Beneath the ocean's surface, there are waves taller than skyscrapers, but they roll within the water, not on it. Internal waves, born where layers of different density meet, can reach hundreds of meters in height, gliding invisibly except for faint ripples on the surface and streaks that satellites can see. In places like the Luzon Strait, these giants travel quietly, a hidden weather beneath the sea. 7. At dusk, sonar once found a mysterious false seafloor that rose every night and sank by day. It turned out to be life itself, the deep scattering layer, billions of small creatures migrating up under cover of darkness to feed near the surface and descending at dawn. The largest daily movement of biomass on Earth happens largely unseen, a gentle tide of living shadows. 8. For centuries, sailors told stories of freak waves. In 1995, instruments on the Draupner oil platform in the North Sea measured one, a rogue wave about 25 meters high. These solitary walls of water can appear from a complex chorus of swells, focusing energy into a single steep face. Rare, sudden, and very real, the ocean's brief, towering breath. 9. Lakes can slosh. A seiche is a standing wave set up in enclosed waters by wind or pressure changes, rhythmically rocking back and forth. In the Great Lakes, A seiche can raise and lower water levels along the shore like a slow-motion tide, sometimes sharply enough to surprise anyone standing too close. 10. Thunderstorms sometimes reach upward, brushing the edge of space with exotic lightning. High above the storm tops, you may catch sprites, delicate, reddish tendrils, or blue jets and haloing elves. Fleeting rings of light triggered by powerful discharges. They bloom for milliseconds, luminous flowers in the thin air of the mesosphere. 11. In Australia's Gulf of Carpentaria, a rare morning glory cloud can unroll like a sky-long rug. It's a tubular cloud, sometimes hundreds of kilometers long, moving slowly across the dawn with smooth, rotating air. Glider pilots surf it. Watchers simply breathe and watch a horizon turn into a floating hallway. 12. Over Lake Maracaibo in Venezuela, lightning returns like a ritual. On many nights each year, warm winds, mountain corridors, and moist air conspire to produce storms that flash for hours. The Catuambo lightning is not constant. Weather is a living script, but it is frequent enough to be a geographic character, riding light in the same place again and again. 13. Even on cloudless nights, the sky glows faintly. Airglow, a soft release of energy from atoms and molecules in the upper atmosphere, paints the heavens with subtle greens and reds, especially from oxygen and hydroxyl. It's the night's exhale, so gentle you need darkness and time to see it. 14. Just after sunset or before sunrise, turn opposite the sun, and you may see the belt of Venus, a pale pink arch above a dark blue band. The blue is Earth's shadow cast into the sky. The rose band is sunlight scattered through twilight air. The planet makes its presence known, quietly as a color. 15. For a heartbeat at the horizon, the sun can flash green. It's a refractive trick, layers of air bending different colors by different amounts, and on rare, clean evenings, the last blink of sunlight breaks into a tiny emerald flare. It feels like the sky winking goodnight. 16. Sun dunes sing when they slide. In deserts from Morocco to California, avalanching sand grains of just the right size and dryness can synchronize, producing a deep booming note around tens of hertz. A dune becomes an instrument. All it needs is a gentle push and the hush of a breeze. 17. Under sea ice, when winter's hand is cold enough, a brinacle can grow, a finger of salt-laden, supercooled brine that sinks and freezes the seawater it touches. It looks like an icy stalactite reaching downward, an underwater icicle that can even freeze small creatures too slow to move away. 18. There is a waterfall in the ocean, a river of heavy water flowing beneath lighter water. The Denmark Strait Cataract forms as cold, dense Arctic water spills over a deep undersea ridge toward the Atlantic, dropping about 3.5 kilometers, taller than any land waterfall. It moves millions of cubic meters each second, unseen except by instruments and maps. 19. Sometimes the tide runs backward. In China's Qiantang River, a powerful tidal bore, the silver dragon, rolls upstream like a low wall, racing against the current as the ocean squeezes into a narrowing estuary. People gather to listen, first a hush, then a growl, then a traveling crest of white. 20. The greatest tides on Earth run in the Bay of Fundy between Nova Scotia and New Brunswick. Geography funnels water into a long bay at just the right pace, and the range between low and high can reach up to around 16 meters. Twice a day, the sea performs a deep bow, and the shoreline changes like a slow theater set. 21. The deepest human-made hole in Earth's crust is the Kola superdeep borehole in Russia, reaching about 12,262 meters. Down there, rock grew unexpectedly warm, roughly 180 degrees Celsius, and behaved more plastically than anticipated. Fluids locked in minerals seeped out under pressure. It wasn't an empty abyss. It was dense, hot, and full of geological whispers. 22. Earth's inner core seems to rotate a little differently than the mantle and crust. Studies suggest this differential rotation may speed up or slow down over decades, subtly changing the timing of seismic waves that pass through. It's as if the planet has a heart that sometimes beats slightly out of step with its ribs. 23. Over the South Atlantic, Earth's magnetic field is unusually weak, the South Atlantic anomaly. Satellites passing through this zone encounter more energetic particles, so operators often power down sensitive instruments there. It's a reminder that our magnetic shield is not uniform. It ebbs and flows like weather over centuries. 24. The record of magnetic reversals is written in the seabed. As molten rock erupts at mid-ocean ridges, iron minerals align with Earth's magnetic field. As the lava cools, that direction locks in. The ocean floor displays mirror image stripes of normal and reversed polarity on either side of the ridges. The last full flip, the Bruns-Matuyama reversal, was about 780,000 years ago. A brief excursion called Lashump flickered around 41,000 years ago. 25. Deep inside, our planet generates its magnetic field through a geodynamo convecting, electrically conducting liquid iron in the outer core. Heat loss, compositional connection, and the slow crystallization of the solid inner core supply energy. That invisible engine makes compasses point, auroras dance, and life on the surface a little safer from the sun's charged particles. 26. In a tiny inclusion inside a diamond from Brazil, a high-pressure mineral called ringwoodite was found containing water within its crystal structure. That hint, along with seismic clues, suggests the mantle's transition zone might store vast amounts of water as hydroxylin minerals, perhaps as much as the mass of several oceans locked away in stone. 27. Seismic waves sometimes focus at the point opposite a large earthquake, the antipode, creating subtle increases in shaking. The physics is like optics. Waves curving through the planet can meet again on the far side, a faint echo of the original event. It's not dramatic, but it's elegant, a planet quietly playing with geometry. 28. After a very large earthquake, Earth rings like a bell. Global seismometers record free oscillations, whole planet modes that last for hours to days, at periods measured in minutes. The planet vibrates in graceful patterns, some where it subtly expands and contracts, some where it wobbles in petal-like segments, a reminder that even rock has music. 29. In a hidden canyon of Australia, botanists found a tree they thought had vanished with the dinosaurs, the Wollemi pine. Discovered in 1994, fewer than 100 mature trees survive in the wild, protected now by secrecy and care. Its ferny, bubbled bark and deep green sprays are a living page from a very old book. 30. Along certain quiet shores in Western Australia and beyond, living stromatolites build layered domes from sticky microbial mats. These structures are cousins of the oldest fossils on Earth, some over 3 billion years old. They make their world grain by grain, a breath captured in stone. 31. On high, dry slopes in the American West, Bristlecone pines endure for nearly 5,000 years. Their trunks twist, half dead and half alive, holding tight to thin soils where storms come slow. In their rings, you can read droughts, eruptions, even changes in the sun. A tree listening over millennia. 32. In some forests, tree crowns stop just short of touching, leaving thin channels of sky, crown shyness. The gaps may help reduce leaf damage in wind or limit pests, but no single cause is universal. Whatever the reason, it makes a canopy look like stained glass, each tree careful not to press too close. 33. Beneath our feet, fungi weave living networks that connect roots across a forest. These mycorrhizal threads trade sugars for minerals, and in some experiments, seedlings share carbon along the network. Signals of stress can also pass through. The forest isn't just trees in parallel. It's a soft circuit of life. 34. Across Namibia and parts of Australia, fairy circles, regular polka dots of bare ground amid grasses, form striking patterns. Evidence points to self-organization driven by plant competition for water, sometimes helped by termites. The circles arrange themselves like hexagons to share scarce moisture, a pattern mathematics would recognize. 35. Plants under stress can emit faint ultrasonic clicks, recorded in lab studies at frequencies beyond human hearing. Drought or cutting seems to increase the rate. The mechanism likely involves cavitation in xylem, as air bubbles form and pop. If a quiet greenhouse had ears tuned high enough, it might sound like distant rain. 36. In Utah, a single organism called pondo looks like a forest of trembling aspens, about 40,000 stems across 43 hectares, but those trunks all share one root system. Pondo could weigh thousands of tons and be thousands of years old. Each new shoot is a note from the same ancient root, played again. 37. On rare, sprawling nights in the Indian Ocean, sailors have reported milky seas, water glowing steadily, horizon to horizon. Satellite sensors have now confirmed these luminous events, sometimes covering tens of thousands of square kilometers. The glow is bioluminescence, likely from vast colonies of bacteria, turning the ocean into a pale lantern. 38. In Puerto Rico's Mosquito Bay, the water shines at the brush of a paddle. Dinoflagellates, tiny plankton like Pyrodinium bahamens, spark blue when stirred, a chemical sigh called bioluminescence. On moonless nights, each stroke of a hand paints light that fades as quickly as it blooms. 39. On Middle Island in Western Australia, Lake Hillier stays a vivid pink. The hue comes from salt-loving microorganisms, algae and archaea, thriving in its hypersaline water. Seen from above, it's a rosy oval framed by dark green forest and pale sand, quiet as a jewel in a shallow box. 40. In Antarctica's McMurdo Dry Valleys, a rusty stain pours from the Taylor Glacier. Blood falls. The color is iron, oxidizing as briny water emerges from a subglacial pocket where sunlight never touches. Even in ice, there are old stories stored in salt. 41. In the polar stratosphere on the coldest winter days, mother of pearl clouds, polar stratospheric clouds, shimmer with iridescence. They form more than 15 kilometers up when temperatures plunge below about 78 degrees Celsius, letting nitric acid and water condense. Their beautiful surfaces also help activate chlorine that can deplete ozone when spring sunlight returns. 42. When sunlight does return to Antarctica each spring, the ozone hole blooms and then heals. The chemistry has been softened by the Montreal Protocol, which phased down substances that release ozone-destroying chlorine and bromine. It's a global proof that the atmosphere listens slowly, but it listens. 43. On sunburnt rock faces in deserts, you may see a dark glaze called desert varnish. It is a skin of manganese and iron oxides, clay, and microbes, built micrometers at a time from dust and dew. Some varnish grows so slowly, micrometers per century, that it becomes a timeline you can touch. 44. When lightning strikes sand or soil, it can melt a glassy branch called a fulgurite. The glass preserves the path the current took, a frozen lightning bolt you can hold. Each is unique, a vitrified sketch of a single electric heartbeat. 45. In the Sahara and Eastern Sahara fringes, a pale green glass, Libyan desert glass, lies scattered in the emptiness. It likely formed about 29 million years ago, from the heat of a meteor impact or airburst, fusing sand into silica glass. Ancient artisans set a piece into a scarab found in Tutankhamun's tomb. Sunshine turned to stone. 46. Lightning in storms forges nitrogen oxides in the air, a small but real source of reactive nitrogen. Washed into soils, it contributes to natural fertilization, a quiet rain of nourishment sparked by thunder. Even stormlight feeds the ground. 47. For decades, the sailing stones of racetrack Playa in Death Valley puzzled visitors. Rocks slid across the dry lake bed, leaving long trails. In 2014, researchers saw the process firsthand on a rare cold morning. A thin sheet of ice broke into panels. A light wind pushed them, and stones skated slowly, riding lines in mud. 48. Walk on a frozen lake in midwinter, and you might hear twangs and whistles like a distant sea-fi song. These are flexural waves in the ice, produced by thermal stresses or footsteps, dispersing as different frequencies move at different speeds. The lake speaks through physics, not throats. 49. In Trinidad, a natural asphalt lake called Pitch Lake oozes with tar. Within its sticky, hydrocarbon-rich pools, microbial communities live slowly, metabolizing in an environment that would seem hostile to most life. The lake is both a geological reservoir and a tiny laboratory of extreme biology. 50. Deep in a silver mine in Mexico, a cave of crystals near Nica revealed selenite blades up to 11 meters long. For hundreds of thousands of years, warm, mineral-rich water seeped and flowed just right, letting crystals grow unbroken. Step inside, and it feels like walking through the ribs of a sleeping giant. 51. In Arctic permafrost, sudden craters have appeared in recent years. Blowouts from methane released as frozen ground thaws and pressure builds. These pockmarks are rare and localized, but dramatic. Pop-up windows into the hidden chemistry and physics of warming soils. The ground is not as still as it looks. 52. Beneath more than 4 kilometers of East Antarctic ice lies Lake Vostok, a vast subglacial lake sealed off from the surface for possibly hundreds of thousands of years. It remains liquid under the crushing weight and gentle geothermal warmth. Scientists drill carefully to keep the ancient water uncontaminated, a pristine, cold patience. 53. Satellite and radar studies show that Antarctica hosts not just lakes, but rivers beneath its ice. Water flows in dark channels, lubricating the movement of ice streams, and occasionally draining suddenly to fill elsewhere. The ice sheet is not a frozen monolith. It's a breathing system with secret arteries. 54. Sea ice can be salty and sweet at once. As it forms, brine is concentrated into tiny channels within the ice, forming a network of briny veins that can remain liquid well below the normal freezing point. Microbes live in these narrow worlds, commuting by capillaries, carrying the memory of winter in their salt. 55. The ocean's great conveyor, the overturning circulation, carries warmth toward the poles and returns cold water to the deep. It's driven by winds, by the formation of dense waters in polar seas, and by vast, varied flows. It changes slowly, and when it shifts, climates ripple. 56. Circling Antarctica is the strongest current on Earth, the Antarctic Circumpolar Current. Unblocked by continents, it sails around and around, transporting on the order of 100 million cubic meters of water each second. It links oceans into one great basin. 57. In 2016, a scientific drilling expedition into the Chicxulub impact crater off Mexico's Yucatan Peninsula reached the buried peak ring. The core showed shocked and fractured granite, the rearranged bones of Earth raised in minutes by unimaginable energy. From those rocks, scientists read how life returned to the crater's seas surprisingly quickly. 58. Across the globe, glassy droplets called tektites testify to ancient impacts. Launched molten into the air, they cooled into streamlined forms that reigned over continents. One strewn field, the Australasian, covers a huge swath and dates to about 790,000 years ago, a fine drizzle from a violent sky. 59. In deep-sea sediments, microtektites, the even tinier siblings, hide in cores as microscopic beads. Under a microscope, they gleam like midnight stars. Each is a single drop of melted earth, a snapshot cooled on the way down. 60. In 1986, Lake Nyos in Cameroon released a cloud of carbon dioxide that had built up in its deep waters, suffocating valleys below. The gas was likely volcanic in origin, trickling into the bottom from the crust. Now, engineers have installed degassing pipes that vent CO2 safely in steady columns. A lake learning to whisper instead of shout. 61. In spring and summer, vast blooms of coccolithophores, tiny algae encased in calcium carbonate plates, and turn swaths of the ocean a milky turquoise. Their chalky plates scatter light and brighten the sea. From space, the water looks like a brushed canvas, a great calcite belt swirling in the Southern Ocean. 62. Many marine algae and plankton release dimethyl sulfide, DMS, a compound that becomes airborne and can seed cloud droplets. More DMS can mean more, brighter clouds over the ocean, reflecting sunlight, a subtle feedback. The early CLA hypothesis oversimplified the picture, but the basic dance between life and clouds remains real. 63. Ships used to leave bright cloud streaks, ship tracks, in humid marine air, caused by aerosol particles from exhaust. After new rules in 2020 reduced sulfur in fuels, the number and brightness of these tracks dropped in some regions. Even the clouds remember our choices. 64. Every year, winds lift mineral dust from the Sahara and carry it across the Atlantic. Satellites estimate that on the order of 100 to 200 million tons fly west annually, with tens of thousands of tons of phosphorus fertilizing the Amazon basin, much from the Bodiali Depression. A desert's bones feed a rainforest's veins. 65. The Amazon rainforest exhales moisture through its leaves. Those vapors condense and fall again as rain. This recycled breath streams as flying rivers of humidity, tending to bend southeast and water distant croplands. A forest is not just a sponge. It is a fountain. 66. The Sahel, south of the Sahara, greens and browns with rhythms of the ocean and atmosphere. When Atlantic waters warm in certain ways, rainfall can increase, and grasses follow with surprising speed. Landscape and weather dance a seasonal waltz, each leading, each following. 67. Over tens of thousands of years, North Africa swings between arid desert and green savanna. These green Sahara periods, tied to slow wobbles in Earth's orbit that change monsoon strength, filled the Sahara with lakes and hippos. Rock art shows crocodiles where today there is sand. 68. Long before forests, microscopic architects changed the air. Cyanobacteria over billions of years released oxygen, and around 2.4 billion years ago, the Great Oxidation Event reshaped the atmosphere. Iron in the oceans rusted into banded layers. The sky turned from haze to blue. Life altered the world, and the world altered life. 69. Because oxygen makes new minerals possible. Earth's mineral diversity blossomed after the rise of O2 and later oxidation events. Mineralogists estimate thousands of known mineral species owe their existence, directly or indirectly, to biological activity and atmospheric change. Rocks, too, carry a biological signature. 70. In the Archean, lavas called comesites, unusually hot and magnesium-rich, flowed like liquid metal. They're rare now, relics of a time when Earth's metal was hotter, found in ancient terrains like South Africa's Barberton Greenstone Belt. Touching one is like holding a cooled ember from the planet's youth. 71. Diamonds reach the surface in strange magmas called kimberlites, which can erupt astonishingly fast geologically, possibly in hours. They bring up fragments from deep in the mantle, including the diamonds themselves, which formed more than 150 kilometers down. Each stone is a messenger, carried up by a sprinting volcano. 72. Far below the surface, the deep biosphere is vast. Studies suggest that microbes living kilometers down in rock and under the seafloor hold billions of tons of carbon, a biomass rivaling the life above. They respire slowly, grow slowly, and redraw our picture of where life can be at home. 73. Some of these endolithic microbes literally tunnel into basalt glass, leaving microscopic burrows. They make a living from tiny chemical gradients, coaxing energy from minerals and water. It's a quiet persistence, life using the palette of stone. 74. In the Hadal Trenches, the deepest ocean grooves, a translucent snailfish has been filmed gliding above the sediment at more than 8,000 meters down. Its bones are reduced. Its body is soft. In the everlasting night, it hunts amphipods in water like cold black velvet. 75. Around hydrothermal vents, tube forms called Riftia pachyptella live without mouths or intestines. They host bacteria inside that oxidize hydrogen sulfide and use the energy to fix carbon, a symbiosis built on stone chemistry. In flickering hot springs, red-plumed gardens thrive. 76. On the seafloor in the Gulf of Mexico and elsewhere, lakes of extra salty brine pool in depressions. Their surfaces ripple and their edges steeply drop, a lake within the sea. Many creatures avoid the brine. Others cluster on its rim, where chemistry meets curiosity. 77. Scattered across abyssal plains lie manganese nodules, metal-rich stones growing a few millimeters per million years as layers accrete from seawater. They are round like eggs, with histories measured in geologic patience. In their concentric shells, a slow clock ticks. 78. The white cliffs of Dover and many other chalk landscapes are made from the microscopic plates of coccolithophores that rain to the seafloor in ancient seas. 1,000 trillion tiny shells stack into cliffs that catch the first light. Entire coasts are compacted plankton light. 79. In windy, glacial times, deserts of dust called loess formed where silt settled out from the air. Today, those deposits make fertile soils in places like the North China Plain and the American Midwest. Fields of grain grow out of powdered Ice Age winds. 80. Earth's rotation wobbles slightly, a free oscillation called the Chandler wobble, with a period of about 14 months. In recent decades, scientists have traced changes in the drift of the poles, partly to shifts in groundwater and ice. Even large-scale pumping can move a planet's spin a tiny bit. Our water habits lean on the axis, just by a hair. 81. Civil time occasionally needs a nudge because Earth's rotation is not perfectly steady. Since 1972, leap seconds have been added now and then to keep atomic clocks aligned with the turning of the planet. In recent years, international timekeepers have planned to phase out leap seconds by the mid-2030s, preferring smoother adjustments, time learning to drift gently. 82. In the Devonian, long before birds, a day on Earth was shorter. Fossil corals and tidal rhythmites suggest roughly 400 days in a year, meaning days around 21 to 22 hours long. Tidal friction with the moon has been lengthening days ever since, grain by grain of time falling into the jar. 83. We measure the moon's slow departure with lasers. Astronauts placed retroreflectors on the lunar surface, and pulses from Earth bounce back to the millimeter. The distance grows by about 3.8 centimeters per year as tides transfer angular momentum to the moon's orbit. A long, slow goodbye, though we will never see it finish. 84. Earth has company in its orbit, small asteroids in peculiar dances called co-orbitals. Some, like Kamo Oelwa, circle the sun near us in a way that makes them look like quasi-satellites for a while. Others, like 3,753 Cruithne, trace horseshoe paths from our point of view. They are not moons, but they keep us quiet company. 85. On some nights, you can see the Earth's own face glowing on the moon. Earthshine. Sunlight reflects off our day side and softly illuminates the moon's dark crescent, a ghostly circle within the crescent's arms. It's the planet holding a lantern to its companion. 86. A purplish arc that looks like aurora sometimes appears far south. Steve, strong thermal emission velocity enhancement. It's a narrow ribbon likely tied to fast-flowing ionized gas at the edge of the auroral oval, often accompanied by a green picket fence structure. It's another kind of sky glow, a cousin of aurora with its own quiet personality. 87. In early summer at high latitudes, noctilucent clouds shine electric blue at the edge of night. These are the highest known clouds, forming around 80 to 85 kilometers up when water ice crystallizes on tiny dust particles. Their frequency seems to vary with the upper atmosphere and the presence of methane and water vapor, shining frost at the gates of space. 88. When you stand on a mountain at dawn, you can watch Earth's shadow retreat down the western sky like a tide. The boundary is sharp at first, then softens. It's a small thing, the planet revealing its roundness in the pink of morning. 89. Trees record solar storms. In the growth rings of ancient wood, spikes of radiocarbon mark rare bursts of cosmic ray activity, events around the years 774 to 775 and 993 to 994 CE stand out. You can read a star's hiccups in a tree's careful lines. 90. In caves, stalagmites grow drip by drip, and the ratio of oxygen isotopes in their layers can record past rainfall and temperature. Speleothems are timekeepers of monsoon shifts, droughts, and gentle swings in climate. Stone columns that remember water. 91. In golden amber, bubbles of ancient air sometimes trap tiny samples of past atmospheres, and insects pause mid-flight forever. What you see in the honey light is a moment paused, resin hardened into memory. Hold it to the window, and you hold time. 92. On a beach in New Zealand, the Moraki boulders sit like giant marbles half buried in sand. They are concretions, spherical bodies formed as minerals precipitated around a center in mudstone over millions of years. When the cliffs erode, the spheres roll free, simple and strange. 93. In Romania, smooth stones called trovons seem to grow after rain. They are cemented sand concretions. When wet, minerals precipitate at their surface and can add to their mass, sometimes sprouting knob-like buds. It's geology that looks like play. 94. In the Bahamas and other karst places, blue holes drop as circular shafts into the seafloor. Some have layers of anoxic, sulfur-rich water far below, where bacteria build delicate mats and sulfur shines like milk. Divers descend through time and chemistry as much as water. 95. Inside certain lava flows, when the surface cools but the molten interior keeps moving, tunnels form. Lava tubes. Long after the eruption, skylights open into them and show black rivers frozen mid-flight. Such caves can be long and smooth, perfect analogs for places we might one day explore on the Moon or Mars. 96. When lava erupts underwater, it forms rounded lobes nicknamed pillow lavas. The outer skin freezes as soon as it meets cold water. The interior keeps pushing, inflating the pillow and sometimes cracking it open to make another. A basalt quilt sewn beneath the waves. 97. Volcanic ash clouds sometimes spark their own lightning. Colliding ash particles exchange charge, and strong electric fields grow within the plume until the sky writes jagged signatures through the ash. Thunder in a place with no rain. 98. On windy days with the right kind of snow, the landscape can make snow rollers. Hollow cylinders of snow that roll along, collecting layers like flaky pastries. They look as if a child rolled them for 1,000 small snowmen and then wandered off to sleep. 99. Hoarfrost can grow fern-like on cold. Still nights when water vapor bypasses liquid and deposits as ice, carving feathered patterns on fences and twigs. Rime ice, born of supercooled fog, coats windward surfaces in white spines. Winter draws lace and combs it lightly. 100. In Antarctica's right valley lies Don Juan Pond, a shallow pool so salty, rich in calcium chloride, that it stays liquid at temperatures far below freezing. It is often just a few centimeters deep, looking like a spilled secret on the cold ground. Brine that chose not to sleep, even in a place built for sleep. There, 100 small lanterns to glow in your thoughts as you drift. Our planet is tireless, but not loud. It whispers its most beautiful truths. If you felt a little calmer, a little closer to the earth beneath your bed and the sky above your roof, you're already part of the story. Thank you for resting here in the hypnosphere. When you're ready for another quiet journey, you're welcome to subscribe and return. No rush, only wonder, waiting where you left it. Sleep well.